Hello everyone, how you doing? Welcome to a video on graphing linear systems of inequalities. So we're going to graph the solution set to this inequality right here, the system of inequalities. We have y is less than 2x minus 9, and also have the inequality x minus 4y is greater than or equal to 8. We've talked about the solution to the linear system of inequalities here are all the points, or all the ordered pairs x, y that make both inequalities true. Now here's how we actually go about showing that graphically. We just graph one inequality on the coordinate plane here. Then we graph the other inequality. Both of them have a boundary line, both of them have shaded areas, and then we look for the overlapping shaded part that represents the solution sets of both of them. And that's the target area that we want. That is the system, or that set shows the solutions, all the solutions to the system here. Okay, so basically we just need to go through and graph each of these individually and see what we got here. I've got a couple of different setups. I'm going to use a couple different methods to graph inequalities. So hopefully it's good review for you in graphing. Let's do the first one. So the first thing I need to do in graphing linear inequalities, I need to figure out where my boundary line is. I've got to get that line to know what am I greater than or less than. So we can do that either just by graphing it in slope-intercept form or finding the x-intercepts and graphing it that way. So the first one, if I take a look at this first one right here, y is less than 2x minus 9, I can see that the y-intercept is negative 9 and the slope is 2. It's already in slope-intercept form. So if I want to graph that line, I'm going to go down, mark a negative 9 right there. There's my y-intercept. And my slope is 2, so I go over 1 up 2. Over 1 up 2. I'm going to go ahead and make a bunch of these so I know the general idea of where my line is going. Pretty easy, right? We like slope-intercept form. Okay, so once I have kind of my boundary line established, now I need to figure out, is it a dashed or a solid line? Well, here's where I look at the actual inequality. So this is just less than, it's not less than or equal to, and since it's not equal to that line, I have to do a dashed because this line is the boundary, but it doesn't represent any of the solutions to that inequality. It just helps me mark my greater than or less than part. All right, so there's my dashed line. And now I want all the y values less than that line. So less than means I'm shading down where all the y values decrease. So the solution set to that first linear inequality, y is less than 2x minus 9, are going to be all the points in this blue area below the line. I'm just going to do a really rough shade in. You can kind of see the idea there. All right, there's one of them. Now let's do, I should mark that down. We forgot to do that. Shade, correct side. And it's easy to shade if you have it in slope-intercept form like this because it just tells you the y values are less or the y values are greater. Here we had y values are less, so we shaded down. Okay, the second equation, the second inequality right here is going to be a little bit different. I'm going to use x-intercepts, x and y-intercepts to find a couple points and then graph this line. And then a different method to determine which side to shade. All right, so let's get the boundary line with this one. X minus 4y has to be greater than 8. So I'm going to think of it as an equation for a second. X minus 4y is equal to 8. I want to find that line. I'm going to start by putting in 0 in for x. I'm going to find the y-intercept. So if I put 0 in for x, I end up with negative 4y equals 8. If I divide both sides by negative 4, my y-intercept is going to be negative 2. So right here is 1 point on the line at a y value of negative 2. Now let's find the x-intercept. Let's put 0 in for y. So now I end up with x equals 8. Because this whole minus 4y term, 4 times 0 is 0, x minus 0 is 0. That was really easy. Now I've got the x-intercept is all the way up here at positive 8. Now looking at this inequality, I know enough information to make the boundary line, but I need to figure out, is it dashed or a solid line? This is going to be a solid line because it is equal to, it's greater than and equal to. So I'm going to make a solid line to show all the points equal to it. So I'm going to go and flip into line mode. And right about there. Let's make it cross back this other way. Ooh, that's a great line. So we got a solid line, we got a dash line. I've got my boundary line made, I made it solid. Now I need to figure out which side I need to shade. So in this one, it looks like it should be x minus 4y is greater than, so I should shade up, but I can't really tell with all that's going on. I can only do that if my y value is isolated. So what I would typically do is I use this point 0, 0 as a test point. I'm going to put 0 in for x, 0 in for y. If it makes the inequality true, it's a solution, so I got to shade that side. If it's not true, it's not in the solution set, so I end up shading the other side. So let's put 0, 0 in for x, and 0 or for x and y. So we got 0 minus 4 times 0. Is that greater than or equal to 8? I got to flip back to my inequality here. Well, 0 minus 4 times 0 just ends up being 0. Is 0 greater than or equal to 8? That is not true. So the point 0, 0 is not a solution. So then my solution set is below the line. I have to shade the other side. Okay, there's some interesting things going on here now. We've just shaded, found the solution sets to both inequalities, but the solution set to the system is the place where both inequalities overlap each other. And so what that place is this region right here. So it's going to be, I'm going to do it in purple here. It's going to be along this line, because that part overlaps the blue and red. It's going to be down this boundary line, and it's represented by this shaded part here. So hopefully you can kind of distinguish that a little bit. But there we go. We've got the shaded area. So any point in that purple area should represent a solution. So let's find a nice little test point just to see what we got going on. We're going to pick one point right here. So the coordinates of that point looks like it's got an x value of 7 and a y value of -7. And if I put those x and y values in, we should confirm that it's a solution to the system. So let's put them in for both of them. So for both of these inequalities, let's put -7 in for y. Is -7 less than 2 times +7, that's my x value, -9. And then we're going to put it in for the other one, for x. So is 7 minus 4 times -7, is that greater than or equal to 8? All right, so let's test this first one out. 2 times 7 is 14. 14 minus 9 is going to be 5. So is -7 less than 5? Yes, that is true. All right, so the first one checks out. Let's do the other one. 4 times -7 is -28. So we got 7 minus -28. So make sure we do multiplication first. Now I want to check, is 7 minus -28? That's going to be 7 plus 28. The two negatives turn into positive. So we end up with 35 is greater than or equal to 8. That is also true. So we took that one point in the solution set, the purple solution set here, and we just tested it, and it came back that it was true for both inequalities. So it is a solution to the system. There you go. Hopefully that's helpful for you to understand a nice graphical way to represent all the possible solutions to a linear system of inequalities.